Hey Algebra people. Today we're going to be looking at section 6.6, which is on geometric sequences. And there is a lot of exploration here which you might want to look at on your own, but for the purposes of this video we're just going to kind of skip to it and we're going to get to the actual concepts here. So in our own words, what is a geometric sequence? Now we've actually seen geometric sequences when we were looking at the exponential function. So the geometric sequence is actually an exponential function. But since it is a sequence, we're just looking at an ordered list of numbers that uses multiplication to find the next number in the sequence. So 3, 6, 12, 24, that uses multiply by 2 to get from one term to the next. A term is just a number in the sequence. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. We're using multiply by 2. So this is an example of a geometric sequence. A common ratio, that's just the number that we're multiplying over and over again. So in this example here, the common ratio is actually just 2. So here it is again. This is another way. A lot of people like to write it this way. You'll see me do this as well. If I see that the rule to get from one number to jump from the first number to the second number is times 5, and then the rule to get from the second number to the third number is multiply by 5, then I can see the common ratio is 5. Things can get tricky if we have a sequence of decreasing numbers here, but you'll have to think in terms of division and in fractions. So if I take a look at from 9 to 3, just think about the division. That is divide by 3, and then from 3 to 1, that is also divide by 3, and then you can check and see 1 divided by 3, again that's divided by 3, and then from 1/3 to 1/9, that's also divided by 3. But remember, divide by 3 is the same thing as multiply by 1/3. That's why we practice this all throughout our algebra. So we can actually express this sequence as a sequence of multiplication by 1/3 instead of a divide by 3. And that tells me that the common ratio is 1/3. Now the common ratio is always the multiplication. It's not the division. It's always a multiplication thing. So with that in mind, we have this really important equation here, and we call this the explicit formula for a geometric sequence. This is what we're working on in calculus right now, is this formula. So this equation for a geometric sequence, a(n) is equal to a1 multiplied by r to the n minus 1. Now, a couple of notes here. If we know the first term of the geometric sequence and we know the common ratio of the geometric sequence, we can use this explicit formula to find any other term in the sequence. And we're going to treat the explicit rule like it was a function. Let's go back to these sequences over here that we found. We have this one over here, 1, 5, 25, and 125. We know that first term is 1. And we also know that the common ratio is 5. So we can write the explicit rule as a(n) equals 1 multiplied by 5 to the n minus 1. This is the explicit rule. Now, we can look at the exact same thing with this second sequence that we have. Let's kind of separate it. We know the first term is 9. We know the ratio is 1/3. So that equation for the geometric sequence, a(n), that's going to be equal to 9 multiplied by 1/3 to the n minus 1 power. So just like I said earlier, once you know the first term and the common ratio, just use the explicit rule, put the numbers in the right place, and you're ready to go, which means we're ready to go with our extra practice. Let's see. Is this arithmetic or geometric? Remember that arithmetic means we add, and then for geometric that means we multiply. So let's see. 1 to negative 4, and then 4 to 16, and then 16 to 64. Well, just by my number sense, I can tell that we're not really adding here. But can we multiply? Let's see. 1 times negative 4, yeah, and then negative 4 multiplied by negative 4 again gives me 16, and then 16 multiplied by negative 4 again gives me 64. So this looks like geometric. Let's try this one. 3, 7, 11, 15. Notice how the numbers aren't growing all that fast, or they're not shrinking all that fast. So that gives me the idea that this is an arithmetic sequence. So keeping that assumption, this looks like I'm adding 4 to get from there to there, from 3 to 7. From 7 to 11, again, that's add 4. And then from 11 to 15, that is addition, again, add 4. So this is arithmetic. And then let's do this last one. You got 2, 4, 8, 32. Look at how quickly this grows. 32 is much bigger than 2, whereas 15 in this second sequence wasn't a whole lot bigger than 3. So this looks like a multiplication sequence, and let's confirm that's multiply by 2 to get from 2 to 4. To get from 4 to 8, that's also multiply by 2. And then from 8 to 32, that is multiply by that's multiply by 4 now. So this looks like neither, because we don't have the same, it looks like a multiplication rule, but we don't have the same thing multiplied every time. So this is neither arithmetic nor is it geometric. So moving on to the next set of problems here, we're supposed to write the next 3 terms of the geometric sequence. The first thing I want to do is to figure out, well, what is, the first term and what is the ratio? So let's figure this out. The first term, that's an easy one. That's just 7. And the ratio, now I have to figure out what am I multiplying by to get from one term to the next, because I'm already told that it's definitely a geometric sequence, so I just need to find the multiplication. So 7 to 21, that's times 3. That should be enough for you to figure this out, but of course I'm going to check it again. 21 times 3, yes, that's true. So we just need to figure out the next 3 terms here. So if the rule is multiply by 3 and the last term here is 189, then we're going to put a 189 times 3 followed by, we should multiply that. 189 multiplied by 3, that's 567. And then the next one is going to be 567 multiplied by 3. That's 1,701. And then 1701 multiplied by 3 again is 5,103. So the next 3 terms here are going to be 567, 1,701, and then 5,103. 10 through 12, we're going to do a very similar thing. We got to find out the common ratio. So this looks like I'm dividing by 2, which remember is the same thing as multiply by 1/2. So multiply by 1/2, again multiply by 1/2, and again multiply by 1/2. So the next term of this sequence, multiply by 1/2, that's going to be 3 over 4. And then the next one, I'm going to multiply by 1/2 again. That's going to be 3 over 8. Hope you see the pattern in the denominator. and then I'm going to multiply by 1/2 again, and that's going to be 3/16. And then, of course, we're just going to graph them. Now, if you want to graph them on Desmos, you can type the word table, and that'll give you a table. And then you're going to type in, for x1, you're going to put 1. And what was that first term? It's 12. And then we're going to do 2. We're going to put 6. That was the next number. The next number for the third term, that was 3. The next number for the fourth term, that was 3/2. And then the next, for the fifth term, we had 3/4. And then for the last term, the sixth term, we had 3/8. So you can see, as I was doing that, Desmos was doing a good job in putting all of the numbers here. I'm going to zoom out a little bit, and that will give me a really nice graph of the sequence. Okay, moving on to the next one, we're going to write an equation for the nth term of the geometric sequence, and then we're going to find A6. So, whoa, these are really big numbers over here. I don't know how to deal with this. Okay, I do know how to deal with this, but, you know. All right, so I want to get from 6,561 to 2,187. The quick way to find that number is to go to Desmos and divide those numbers. So if you divide any two consecutive numbers, the first number divided by the second number in particular, you're going to get that ratio. So it looks as though we're dividing everything by 3. So let's check it out. What is 6,561 divided by 3? Oh yeah, that's the next number in the sequence. Let's take that number, 2187, and let's divide that by 3. And oh yeah, that's 729, which was the next term in the sequence. So it looks as though the rule is divide by 3, which, remember, that's the same thing as multiply by 1/3. So the rule here is multiply by 1/3. Now that I know the rule, I'm going to put together my clues. The first term is going to be 6,561. A common ratio is going to be 1/3. And now I can put together my equation for the nth term. So the nth term is going to be equal to the first term, a1, multiplied by the ratio to the n minus 1 power. And we're just going to put in the numbers. So what was a1? It was 6,561. And what was r? R was 1/3. And that looks great. Whoa. Next, let's find the sixth term here. That's going to be 6,561 multiplied by 1/3 to the 6 minus 1 power. Let's make that look more like a 1/3. We'll go over to Desmos and we'll evaluate that. So let's clear things out here. So 6,561 multiplied by 1/3 to the, and then don't forget, if you're going to do a power here, you're going to put it in parentheses. So the 6 minus 1 power. Of course, I guess you could have just done that in your head. You know that 6 minus 1 is 5. So 27 is going to be that sixth term. Don't be confused by 16 and 17. This is exactly the same thing, only it's written as a table. So you can think of it as the sequence 2916, 972, 324, 108. Exactly the same thing, just written in a different way. And then here, with these, again, it's just written as coordinates instead. So we're looking at the y values here, 2, 6, 18, and 54, which means my sequence is 2, 6, 18, 54. Let's work with this one, and I can see that this is a multiply by 3 sequence. So the first term is going to be 2. The ratio is going to be 3. And if I compare that, or if I substitute all of those numbers into the explicit formula, a1 multiplied by r to the n minus 1, well, a1 is 2, and r is 3. So that gives me the explicit formula. Pretty easy. And then now the last thing is, what is the sixth term? And that sixth term is going to be 2 times 3 to the 6 minus 1. Well, you know 6 minus 1 is 5. So let's go on over to Desmos, and 2 times 3 to the 5th power, let's do that. 2 times 3 to the 5th power. Oop, I totally messed that up. 2 multiplied by 3 to the 5th power. That gives me 486. So that's equal to 486. And that's going to be it. It's actually not as difficult as it seems. It's just that there's a lot of variables that you'll have to get used to. I know it took me a long time personally to grasp that concept of the subscript. That is one of the places where in my life I know I completely, I lost control with my algebra. But you're not going to. You're going to do fine, and I'll see you guys on the next one.